So as an example of application of that previous formula for the calculation of the area inside of a closed curve, we're going to do this on the asteroid. So this is the nice picture that you're seeing, and it's described with a parametric curve with x of t is equal to some value a cos cube of t, and y of t is some value a times sine cube of t. We're going to take a is equal to 1 to make it just slightly simpler. And so the idea is that we want to calculate the area inside of that nice curve. Okay, so let's see how we can do that. What we want to compute. So let me remind you of the formula that we have. So let's denote u the inside of this asteroid. So we have that this area is, well, that's always true. It's going to be, it should be given by the integral of the constant one function on this domain. And using the Green-Riemann formula, we saw that we could, if we use the last one, for instance, what we need, we just need actually to find P and Q such that dq over dx minus dp over dy is going to be equal to 1. Okay, so one of the choices would be well, that we saw that we could choose, for instance, p to be negative y and q 0. We could choose p is equal to 0 and then q is equal to x, or we could choose an average of them too, so 1/2 of negative y x. Okay, so maybe that's the one we're going to choose. So that would be the integral, the line integral on the boundary of u of minus y times, well, dx plus x dy. Okay, so let's write what we have here. Okay, let's use this last formula. So the parameter t is going to go from 0 to 2 pi, so that's going to be 0 to pi. So negative y is going to be minus sine cube of t times, we're going to need the x prime and y prime. Why? Because you know that the p dx plus q dy is usually rewritten as p x prime plus q y prime dt, because dx is x prime dt and dy is y prime dt. Okay, so that's the whole stuff about line integral. So I'm going to need our specific x prime. So x prime is just 3 times minus 3 times the sinus of t times the cosine square of t, and y prime, so that's x prime of t, and y prime is 3 times, so we get cos of t sine square of t, that's y prime of t. Okay, so this I had, so p was negative y, so minus sine cube of t times x prime, so times minus 3 cos sine t cos square of t, plus q is x, so cosine 3 of t, times y prime, so 3 cos t sine square of t, that whole stuff dt. Okay, so let's just expand that. So we get, I can even factor with the 3, integral from 0 to 2 pi. So I've got cos square of t sinus power 4 of t plus sine square of t times cos power 4 of t dt. We can factor with cos square sine square, and we have sinus square of t for the first term plus cos square of t for the second term, so you know that makes 1 from Pythagorean theorem. And so this is what I've got: cos square of t sinus square of t dt. So let's use some formulas to deal with that one. Okay, so well, that's one example. You could probably use other tricks like integration by parts or something like that. All right, so let's use the double angle formula. That's a very useful one when you have even powers of the trigonometric functions. So you know that cosinus of 2t is cos square of t minus sinus square of t. So that you can rearrange that for instance, using sine square is 1 minus cosine square, or the contrary, in order to get only cosine square and sine square. So that you get cosine square of t is going to be equal to cos 2t plus 1 over 2, and the sine square of t is going to be 1 minus cosine of 2t over 2. Okay, so all right, so what should we do? Well, let's just multiply them together. I can factor with 1 over 2 and 1 over 2. That's going to be 1 over 4 times the 1 over 2 first. That's going to be 1 over 8. I get, so the cosine square is going to be giving me 1 plus cosine of 2t. And the sine square is going to give me 1 minus cosine of 2t. So maybe you already see why I chose to do it that way, because then 1 plus a plus b times a minus b, that's a square minus b square, so that's 1 minus cos square of 2t. Okay, and again we are going to use the fact that, well, cos square of 2t is going to be cosine of 4t plus 1 over 2 plus 1, the whole stuff, over 2. Okay, so that's we have 1 minus 1 over 2 minus cosine of 4t. So this can be rewritten as 3 over 8. Oh, sorry, I have a 2 here. 3, so I can even factor with a 1 over 2, so that's 3 over 16 times. I had 1 minus 1 over 2, that was 1 over 2, but I already factored with the 1 over 2, so that's just 1 over 2 minus cosine of 4t dt, which of course now I can compute that. That's 3 over 16. Oh, sorry, I already had factor with the 1 over 2. So 3 over 16 times the t minus, so I get sinus of 4t over 4, and between 0 and 2 pi. The sinus term is going to be 0 in 2 pi and in 0. And so I have just 2 pi times 3 over 16, so that's 3 pi over 8. Okay, so this is the area inside the asteroid. Okay, so we will practice some more in during the tutorial, but basically that's the idea. Okay, thank you very much. Bye.